Thank you very much, and yeah, very happy to be here. I think it has been super nicely organized so far, so well done to the team here. Yeah, so I would like to talk to you about vetKeys. There was a bit of a typo in the program, so the V was missing, but we'll get to that. And it's quite nice to actually be one of the people speaking towards the end of the conference, because you kind of start to see what everybody knows, what we kind of all agree on, where is the kind of level in the community. You see that, you know, privacy is an okay thing now, everybody is okay to talk about it. You see that L2s are flying, it's a goer. We're actually going to build stuff. It's not just about transactions anymore. It's like, okay, we're going to build tech now, actually. And we're going to build systems, and we're going to build actually the foundations of the society that ETH promised us all those years. So that's a little bit of a context to say that actually we are there. If we want to do these modern societies, they're built on digital frameworks, and this includes all sorts of stuff like social media, communication, storage, sharing, financial systems, supply chain, medical records, like all sorts of stuff is delivered online with tech stacks. So if we are going to do all of these things and actually build this thing, like future and society that we want, it needs to be done with interesting infrastructure. And so a question is, what kind of infrastructure should that be? Should that be Google? Should that be these kind of big corporations? Should it be the types of people who can do censorship, or who can do change things, or yeah, whatever. Like it's, they can charge what they want, all this kind of stuff. So building this kind of new modern society that we want, the kind of promise of ETH and Bitcoin at the beginning, kind of takes, yeah, maybe a more decentralized tech stack. So with that in mind, this is kind of our goal, where I see the whole industry and the whole conference is at now. We're kind of all there. Yes, we are going to build the tech. How can we actually do that? And so as I was introduced, they said that I was from DFINITY. I am a researcher there. And DFINITY is one of the major contributors to building this internet computer. And there's a whole bunch of stuff that exists already that is kind of getting us on this pathway to this new utopian digital society. So I wanted to put in context a little bit the privacy story by introducing some of the features that are kind of getting us partially there. So one of them is this verifiable web. So one of the big problems with the internet as it exists today is that things are not verified very well. And so if you're looking at a deep fake, or if somebody's kind of spamming, or some things can be, yeah, it's like not always clear who you're actually talking to or who is actually communicating with you. So it would be much better if we had an internet where we could do verification and we could trust the actual things that we're seeing. And this would be really great. So one thing that we can offer today already is this verifiable web, because the structure of the internet computer is kind of built up in such a way that everything communicates, every message is signed, everything that's passed around is managed and verified by this one single public key. This is like our God key that we can all kind of raise our hands to and praise the key. But there's one public key from which everything that happens on the internet computer can be verified. So if you're running any sort of computation in a smart contract, or if you're engaging with the blockchain from the internet, everything that you receive will be signed with this key. The actual key is there. That's it. You can go and put it in your pocket and save it for a later day when you actually want to verify anything that comes from the internet computer. The things that you can do with this key are, yeah, verify interactions. So if you're talking to the machine, you know that this is the machine, the correct machine. It's not somebody, there's no kind of man-in-the-middle attacks or anything like this. And you can also verify correctness. So any computation that is done, you can verify that it was done correctly. That's that. Oh, I went too far. The next thing is multi-chain. So now that we can actually know that we have some security or kind of some safety in who we're talking to, let's start talking to some people. And so one of the things that would be nice is to be able to talk to other blockchains. So operating on the internet computer is great, but there's a lot of activity on Ethereum, and there's a lot of kind of security and great properties, and we're all here because of Ethereum, so it would be good to be able to talk to Ethereum. And so we can. we really wanted to kind of build this idea of the world computer where, you know, you have Bitcoin as a very nice store of value, Ethereum as this very nice kind of computation, very security intensive, decentralized layer, and then this kind of internet computer to bring everything together. We can talk to other blockchains now via this threshold signing that we have implemented in the internet computer. So these nodes, which are equivalent to our validators, are connected via subnet. They can sign, they have secret shared keys. They can sign a transaction, which is essentially the same as your wallet signing a transaction to the Ethereum blockchain. So it acts as a proxy for you. We can also talk to Bitcoin and canisters. So these little cylinders on the subnet are canisters. So these are representing our smart contracts on the internet computer. And these can also sign Bitcoin transactions natively. And then there's a kind of Bitcoin twin, which can act as a currency inside the internet computer for quick and cheap Bitcoin transactions there. So then, now that we can talk to other blockchains, maybe it would be good to talk to the internet. Some people call this the Oracle problem. I like to say, let's just talk to the internet. Can we do this? Yes, we can. So we also have a way to talk outside of the blockchain. Canisters, so these smart contracts on the subnet, call to Web 2. The nodes or the validators then go get that URL. The servers return the URL. I'm being very quick, but like just to give you an overall view of what some of the things that are possible. Then the returned information from the servers goes through consensus in the nodes, and then it's verified to be correct by the design of the system and is delivered to the canisters. So this is a way that we can talk to the internet. And so this is very nice. It means that, you know, Web 3 and Web 2 can be this kind of continuum. It's not the case that there's any sort of separation between blockchains. We can talk across the internet. We can talk to everyone now. This is great. So what to do? Now that we have this kind of, at least most parts of this utopian tech stack that we want, maybe it's time to start using it in the real world. And this is where shit gets crazy. Sorry for swearing. But so right now, the tech stack that is used by the real world is Google, Microsoft, Facebook, blah, blah, blah. If you want, let's say, your passport to be issued digitally, if you want, I mean, pretty much anything in your day-to-day life to be done digitally, it's going to be a big corporation that's doing it. And when it comes to identity and like your life, maybe that's not always the best thing. So it would be nice if we could have some kind of private way of doing these things and in a decentralized way. So you want all this nice decentralization, but at the moment all this nice decentralization is very public. And that doesn't work when you want to get something like a digital passport. The other thing is that, yeah, Google can censor stuff. They can change what you see, they can change your user base, they can change a lot of stuff. This is not good. So we don't really want to depend on corporations, but at the same time, for some things like passports or national things, it's not so good to be working fully in the public. So this is why we come to the last kind of problem of privacy. And what we wanted to kind of talk about today was a method that we have introduced, a tool, an API that people can use to actually get the keys that can give them the privacy that they need in a very kind of seamless and easy way. So how do we do this? Here we go into a bit the fun technical side of stuff. So earlier I said that canisters, so these smart contracts can create and sign transactions on other blockchains. So if you want to think about privacy and actually getting privacy in an interesting way, really all the change that you need to do here is that you want to sign and also encrypt and decrypt and maybe arbitrary data rather than just transactions. So instead of just signing transactions, it's like, okay, I can also sign, I can also do decryption, I can also do all the kind of fancy cryptographic stuff that we like to do with keys. So this is the love letter to keys, basically. So yeah, this is the goal of vetKeys. So how does it work? It's just a threshold key derivation. So I don't know if you know much about cryptography or if you have any experience, but key derivation, you can think of it like a password. If you put your password into a browser and then it's stored somewhere, it's often kind of a new key is derived from this. It's just this. This is kind of the 101 of sort of privacy online. So there's one master key that is secret shared across the nodes. And then from this master key, the derived key is derived. Like 10 points to the person who starts to see something already wrong with this picture. So I said that the goal is to get a key that can help us to do encryption, decryption, signing, and stuff like this. But I derive this key and I send it straight to the canister in this network, which I'm claiming is public. This is not necessarily good. If this should be a private key, it should not be seen by anybody. And so, yeah, the canister can see this key. This is not good. So we need the key to be encrypted. It needs to be returned to the canister in an encrypted way so that the canister or the smart contract or the network or whatever cannot actually see this key and use it. How to do this? The normal way. The user will generate a transport key pair so that when they actually ask or make a call for this vet key, for this derived key, they also send a public key under which the nodes, when they're deriving the key, can encrypt. And so then they send this encrypted key back to the user. Then the user can use the secret transport key to decrypt and actually retrieve the vet key and use this for signing, encryption, and whatever else they want. That's that. Then, as a little note, vet keys are deterministic so that they can be retrieved later. And this is why we have this derivation ID here. So like, it's not very useful if you can just generate a key once. You also want to be able to come back later and say, hey, remember that key you gave me? I now want it again to do decryption. And so this is why we have the derivation ID. Finally, as I've mentioned before as well, by the kind of design of the system, the internet computer has this verification process. So every computation that happens is verified and shown to be true, and there's no different here. And so this was the V that was dropped from the program. So yeah, we have this verifiably encrypted threshold key derivation. And this is now vetKeys. So if you see vetKeys anywhere, hopefully you know a bit more about what it is. So now that we've talked about what it is, it would be nice to see what can we actually do with them. Well, there's a few things. This is the slide where I'm supposed to lose you. It's if you are into crypto, this is maybe more interesting. If you're not, bear with me for a minute. So vetKeys came from a paper. The paper was released earlier this year. It's on ePrint, you can go check it out. It's a lot of description about the scheme. It's proved in very interesting ways. So yeah, take a look at that. It leverages the fact that BLS signatures are also decryption keys of a Bonnet Franklin IBE. And this is where we get the encryption side from the derived key, because the derived keys are BLS signatures, but then they can be used for encryption. It uses ETHMilan to do encryption of the key shares, so the transport key that I said that allows the key to be sent back to the user without being seen by the canister or the network along the way. There we use ETHMilan, and the reason why we used this is because it's very nice in the sense that it has this additively homomorphic property, because if you start to see how can we encrypt pieces of keys and then somehow put it together and still somehow know if this is a good key or not, because if we don't know if it's a good key or not, the machine won't go because it does this verification and everything. So ETHMilan solves this very nicely and everything just works completely easily. There's an API which we are proposing. It's still open for discussion. It's not implemented yet. It's available and the full integration is coming up. The expectation is that we can generate hundreds of these keys per second, so it's pretty efficient. Now, let me talk a bit about the uses of vetKeys. One of the main kind of easiest things to see that these could be used for is end-to-end encrypted messaging. And if you don't know about identity-based encryption, this is a very kind of nice use case. So now the way end-to-end encryption usually works is that I have a key. Yeah, I mean, I won't go into it, but a very easy way to do this with an identity-based encryption scheme is that I, as let's say Alice, just encrypt a message to Bob under his public identifier, which can be a key, can be a wallet address, it can be an internet identity, it can be whatever. It's just some public identifier that is Bob's. And then Alice sends the ciphertext to Bob. Bob then calls to this vetkey API to say, hey, can I retrieve the decryption key for this public identifier? It will derive the encrypted key, send it to him, he decrypts it, and then he can use his decrypted vetkey to decrypt the message from Alice. So this is one kind of quick and easy way to do end-to-end encrypted messaging, for example, with vetkeys. And so there were some nice talks yesterday about encrypting transactions in the mempool. And we were kind of watching it because we do something very similar. And or well, these could be used for something very similar. And I really loved this talk and this organization because I think they're doing great things. And so I want to encourage lots of other people to be like them and do other interesting kind of privacy things like them. And please start here because this would be great. I would love to see this. Another thing is, yeah, the front-running protection. So this is exactly what I mentioned. There's this problem or not problem. This is one of the things that I learned over the last few days, that it's kind of unclear whether front-running is a problem or not, because it can be quite a nice security mitigation, but then it's also something that harms users a lot. So yeah, anyway, if somebody would want to do front-running protection, you can use vetkeys to do it in a kind of nice way. So the user would encrypt transactions to the future. So say a future block number, and then sends these encrypted transactions to a DEX. A DEX commits to some ordering of them. And then later when that block is reached, the DEX can request its vetkey to decrypt the transactions and actually execute them. Another thing is seed phrase backup. So this is something that a lot of people struggle with. They lose their keys, they lose their seed phrases, and they don't know how to get back into their wallets. So one thing that a user could do here is request a vetkey under a given identity, encrypt their seed phrase under that, and then later if something happens or they need to reconstruct their wallet, they can request the vetkey under their public identifier and decrypt the seed phrase. And so this is actually a community project. It's something that's being built by someone in the community at the moment. Another thing that's being built by someone in the community is this sort of variation or extension of the dead man switch. So that they have this problem that they have a substantial amount of Bitcoin that they want to pass on to their kids when they eventually get old and don't want to mine their Bitcoin anymore for whatever reason. Yeah, so the question is how to pass on Bitcoin keys in the case of a bad event. And there they, let's say, encrypt their Bitcoin keys to their kids' identifiers such that later, at a point in time, whenever maybe someone dies or something is wrong, the kids can actually then request a vetkey to decrypt the Bitcoin keys. So this is also a community project, something that is being built at the moment. So that's kind of some inspiration for you of, I think, things that are that we'd love to see being built and companies that we'd love to see started to actually go and do these things properly. We put the tools there, now we're asking you to pick them up essentially. So just one last thing I wanted to tell you about, we had these vetkeys bounties. So we kind of proposed this API, put it out there, but we also wanted to somehow incentivize developers to actually pick up the tools, start playing around with them, let us know if they actually serve their use cases, if they find anything wrong, if they have any suggestions, all this kind of stuff. We just wanted some feedback. And so we had like many nice submissions, but I wanted to show you just a list of the ones that kind of won some prizes in various categories in these vetkeys bounties. It's also just a bit more kind of inspiration of the kind of variety of things that you can do with vetkeys. It's very kind of a super versatile tool. So there was a document-based proof of personhood where deriving keys from MetaMask addresses and doing all sorts of crazy stuff. I just checked the time. And then the form thing, end-to-end encrypted forms. So these are kind of all the little ways that you can see how to maybe start replacing the traditional tech stack. Rabbit Hole is an encrypted file service. There was a browser-based AI chatbot where the conversation between you and the chatbot was encrypted. Nostr, so there was a simple Nostr client running on the IC where they do the key management with vetKeys. MedPX, where they are keeping electronic medical prescriptions encrypted, and then the user or the owner of the prescription can reveal it to whoever they want. There was a time capsule that managed switch for files, so this is a classic case of kind of an interesting thing for journalists often. There was a note-sharing application, and there was Guild Notes, which was, encrypting and sharing role-based content in a gaming community. So, and these are all of the, a few of the front ends, and I kind of wanted to put them here to say one last thing, is that also these are hosted on-chain as well. So all of the front ends are hosted on-chain. So given that we can talk to other blockchains, given that we can talk to the internet, given now that we're getting privacy, this is kind of the kind of future reality that we hope to see actually emerging. And yeah, that's it for me. So if you like, I can answer any questions, but I would really just urge you to go and build some privacy stuff because it's now kind of easy. Thanks very much.